which said that we should decrease our carbon emission. Now, that's wonderful. You could call a conference tomorrow, and the topic would be to condemn cancer. And I can assure you that all country representatives would unanimously vote to outlaw cancer. There's a little problem. How? It's the same trouble with Kyoto. Kyoto was able to say only the existing popular things. We should outlaw or limit the generation of carbon dioxide. And how you do this would be that somehow, not say how, somehow mankind will come up with some way to solve its problem. And Kyoto suggested the only initiative was an economic, a monetary initiative. They said that there should be for each nation giving a certain amount of CO2 they can let up into the air, a quota. Now, their allotment can be solved. If they in one way save or find some way to produce less CO2, they can sell their quota to others. This is now called cap and tax. And our government is budgeting. I don't know if you follow. It's not so easy to follow because now we are tossing around trillions. It used to be millions and billions. Now we are at the trillion level. And the government is budgeting an income in the next decade of $1 trillion from collecting this tax on carbon use because we are putting up too much CO2 into the air. They also says that the culprits are the major oil companies and chemical companies and coal companies. Now, as a taxpayer, I find this remarkable because, you know, if ExxonMobil is regulated that they need to pay so much tax for the CO2 their refineries and plants and so on generate, you are not hurting ExxonMobil. They just simply add it to the price you pay at the pump. Just follow what's happening at the pump. So we as individuals are paying all for it. And is there any way, besides what I consider a very ill-conceived economic or punitive action, which isn't solving anything? You see, the air belongs to everybody. It really doesn't matter who lets up the CO2 in the air. In 2 weeks, it equilibrates around the world. We can be the most CO2-saving country on earth if the rest of the earth is happily letting CO2 up in the air. The atmospheric CO2 isn't changing. So we need to have technological solutions. And practically nobody really talks about it. The only technological solution is called sequestration. And sequestration means that you capture and collect CO2, and then you put it down underground or at the bottom of the sea. Out of sight, out of worry. And this is starting to happen in different parts of the world, including the state of California has great plans to force sequestration and so on. Oh, as a temporary measure, I guess it's inevitable. They put it in exhausted mines, in oil fields and so on. But there are very big problems with sequestration. One, it's only a temporary measure. You put it down, but nobody is answering you how long it will stay down there. 14 years ago in the African country of Cameroon, around the lake, something happened overnight. And all the people living around the lake and all the livestock and everything which was living died. Okay, 10,000 poor Africans died. It wasn't a big news item for the world. But imagine if this would have happened in San Francisco, or Los Angeles, or Shanghai, or of Tokyo, or in Bombay, or many other places. And millions of people would have died. Because what happened was, eventually, scientists found out this lake was a volcanic lake, an exhausted volcano, filled up with water over a long period of time. And from the earth, CO2 was still seeping up in the crater lake. And at the bottom of this lake, a big bubble of CO2 was formed. And one night, as excuse me, one night, as geologists later reported, a geological event took place. In other words, there was a small earthquake deep down in the earth. But it was sufficient to disturb this bubble. And this big bubble of CO2 came up. And CO2 is heavier than air. And therefore it suffocated every living being in the neighborhood. Now, if this would have happened in California, or China, or India, and millions of people would have died, it would have realized a major disaster. Now, I am not saying that this thing is necessarily happening tomorrow, but it could happen and it will happen. So sequestration is only a temporary measure, a very expensive measure, and a potentially very dangerous method. So what is the other alternative of this? To my great surprise, I haven't seen any of the large organizations, the struggling oil companies, being embarrassed that they make too much profit, or countries who spend huge amounts, including our government. This is that there are ways. We found reasonable ways that you can chemically recycle CO2. And what you can recycle CO2 is a very simple chemical called methanol. Now, all what you need is to add hydrogen. If you want to write this in an equation, when you react CO2 with hydrogen, you form methanol and water. It's not very economical because 1/3 of your hydrogen goes into water. And the cost of this is really generating hydrogen. Hydrogen is not present on planet Earth in its free form. There's a simple reason for it. We live in an atmosphere which has 20% oxygen. And hydrogen and oxygen have a very wide love affair. If they can combine, they combine frequently with explosive fervor. So you can't have hydrogen and oxygen together simultaneously. So, of course, hydrogen is very abundant because we have water or we have hydrocarbon, all right, methane just as the prototype of it. We have unlimited amount of hydrogen bound. Of course, you need energy for this, to liberate hydrogen and make it combine. And we have worked out new chemistry which we were able to go around this cycle and not forming water. And one of these approaches is what we call bioreforming. As long as we have natural gas, which is basically methane, you can react methane with water and CO2. And this forms exclusively methanol. Now, if you don't have natural gas or methane anymore, and you know methane is also produced by coal production. Big coal mining operations produce a hell of a lot of methane called coal bed methane, which they must dispose of it because it can be explosive. But even if we would run out of hydrocarbons, we never will run out of water. And when you electrolyze water, you produce hydrogen and oxygen. So what I'm telling you is that by fairly simple and proven processes, you can collect excess CO2, initially from sources where they are in high concentration, like power plants, like cement factories or aluminum factories. But it also comes from natural sources. When you produce natural gas in many parts of the world comes out of the earth together with significant amount of CO2. In the North Sea, which is still a major producing area of natural gas, it's around 10 to 15%. Algeria has large natural gas resources, which the French explore and transport to Europe. This contains 40 to 45% of CO2. And these are huge amounts. And in the past, they were just let up in the air. Now, increasingly, because worried about it, they are forced to do something, and what they do is they store it. So what I am simply saying is, to end up all this, that it's entirely within our capability to create a technological or man-made carbon cycle in which the carbon dioxide formed from natural activity of life activities or from burning carbon-containing fuels should be captured and recycled. And you recycled it into a very simple chemical, and now the last thing is why this compound called methanol, which is not my invention. It's known for 250 years. It was called wood alcohol. Of course, it's toxic, but on toxicity I can only tell you that diesel oil or high-octane gasoline is also toxic. I haven't seen anybody drive up to a pump and ask a pint of the best diesel fuel to drink. And why? This is a very excellent fuel. You can mix it today into gasoline, and you have a flex fuel. This has a high octane number, and within reason, the modification needed are trivial. That's not I saying this. This is well known. Now, one other way of this is that if you have methanol, you can split out water and form a derivative called dimethyl ether, or DME. This is one of the simplest chemical operations. DME is already produced in the Far East in multi-million metric tons amount per year. It's an excellent diesel substitute. In other words, there are more cars, trucks, and so on running in the earth on diesel fuels than on gasoline. And it also can be mixed in household gas. You know, this is also a big problem in many places. For example, in Western Europe, the Russians dominate natural gas supply of Western Europe. And they close down the pipeline, generally in cold winter. And therefore people have very little choice. They either play through the nose or they freeze. So DME and methanol are not just, I'm telling you, things. We used to be a technology leader in the world. Unfortunately, in some areas, we are not anymore. China, 2 years ago, decided that the main alternative fuel will be methanol. And China is building up to 100 world-scale methanol plants. Each plant is going to have a capacity from 1.5 to 3 million metric tons a year. This is not a small operation anymore. And in China, in South Korea and Japan, DME is already today a large-scale product. And just to end up, if some of you are interested in chemistry, you can also take methanol and put through a catalyst and split out 2 waters and form ethylene. Or if you take excess methanol, you can produce propylene. Now, as some of you may know, presently the petrochemical industry is producing all the products we are using, plastics to pharmaceutical to all kinds of synthetics and so on, from building blocks. And these building blocks are ethylene and propylene. And these building blocks are derived from natural gas or oil. But if we are running short or it's getting too expensive, we know that we can produce them all from the same starting source, which we can produce by recycling CO2. Now again, don't take this that I'm telling you some fable. There are already presently a number of very large-scale ethylene and propylene plants in operation, producing the olefin starting material from methanol. And these are, again, multi-million metric ton per year operation. So to end up this, I try to end up on a very positive note. I was a chemist who enjoyed my chemistry for many years, and I published in many areas, and I enjoyed doing all kinds of studies which had no particular interest. In my last 15 years, I got interested in studying the chemistry of the most assuming carbon compound, carbon dioxide. My friends and colleagues warned me that this is crazy, it's too simple, not interesting, and so on. As it turns out, this may be all the case, but you know, things can be simple, but still important. And I do feel that we have certainly at least the foundation for future generations to provide not only essential fuels, but essential starting materials. Look, even food. In the 1980s, in England, ICI, which at the time was the largest chemical company in Europe, produced single-cell proteins in a plant with a capacity of more than 100,000 metric tons a year, not a small operation. By fermenting 1 methanol in the presence of ammonium salts and producing single-cell protein for animal feed. Now, a pig has no choice what you are feeding the pig. Human beings are more picky, but good French chefs, I am pretty sure, can create from different protein, synthetic protein starting material, very good tasting dishes. What I'm telling you is that CO2 can be a very useful general starting material for most essentials of life. And we have, for example, a process developed which won't be in practice in my lifetime, but which is using air as a raw material, not only to produce CO2 recovered and product, but you hear a lot about the need for clean water or desalinated water. And desalination of seawater costs a lot of energy and money. There's an alternate way. If you use air as the raw material, and you see the air belongs to everybody. Oil, nature put in some places, under the Arabian desert, under God-forsaken areas in the Arctic region, whatever. But air belongs to everybody. And if you start to use air, first you take out moisture. And there is a lot of moisture in there. And when you take it out, it's very pure water. Then you can take out carbon dioxide. And then you can take out nitrogen and oxygen. And from these building blocks, by the application of chemistry and technology, you can build practically everything. Okay, heavy metals you still need from other sources. So the future, I think, is very positive. We don't need to easily panic. And certainly I think that not only in the medical sciences, in the biological sciences where your interest is, but even in this area, which is not your field, but as users you are interested, there is a very, very promising future, because humankind won't run out of raw materials and ability to produce a better life for future generations. Thanks for your attention.
Thanks. Any questions?
Yeah.
I have a couple of questions for you. First, if I think about the concept of recycling the carbon at a system level, eventually the carbon is going to be released again when we use the methane, right? Or, sorry, the methanol. So that would imply then that if we had a perfect system where we recycle all of the carbon and our only fuel source was methanol, the level of carbon would remain constant. So do you agree that in that case, basically the best case scenario is that our level of CO2 would remain constant? And if that is the case, then the second question is, do you have any concerns about how that will affect our climate?
Now, what you said, of course, is true to some degree. On the other hand, I can give you a scenario that if you recover more CO2 from the air than you put up, then it's not constant anymore. You can decrease excess CO2. It may take a while, because we were putting up too much now. But in principle, this carbon cycle can be also a cycle in which you take out more CO2 than you produce. And then you can decrease it. Now, your second question was climate change. Look, the numbers are very big. I am not telling you that we will have an instant effect on climate change. Mostly because the fact that human activity is only a part of the